All right, what we're going to do here is determine what shape we have based on these things. We're going to find the slope of the sides first. That's going to tell us is it a parallelogram or not. All right. The second thing we're going to look at is the distance of the diagonals. And this is where we're supposed to know the rules. Which ones have diagonals that are the same? Rectangle, square, and isosceles trapezoid. So that's where we're supposed to know the rules. All right. If it's different, which ones have different parallelogram and rhombus? Possibly a kite, but we'll get to that in just a second. We're going to do the midpoint of the diagonals. All that's going to really do is verify that it's a parallelogram, which we're going to know from number 1. Basically, what I'm doing right here with number 3 is trying to give you easy questions to answer to help you out. It's not going to really tell us any new information, but it's going to verify what we found in number 1, whether it's a parallelogram or not. And then the last one, we're going to do the slope of the diagonals. It's going to help tell us rhombus or square. And really, I probably need to put some more stuff in here. If it's perpendicular, it's a rhombus or a square. If it's not, it's parallelogram or rectangle. But we'll answer the questions, answer these questions, and then we'll be able to say what we're looking at, what kind of figure. When I graph this, let's see, 2, there, 2, 5. All right, based on my graph here, what does it look like?
Rectangle.
It looks like a rectangle. But now we just can't say, oh, it looks like a rectangle, so we're done. We're going to have to answer all the questions on this, then prove that it's a rectangle. First thing we're doing is slope of the sides. Now, the slope formula. I've got to do the slope, the distance between the y's over the x's. So AB. What I would do if I were you is this. A is my first point. Well, I'm going to say there's X1 and Y1. That's my first point. And then B is my second point, where there's X2 and Y2. And all I've got to do is plug those numbers into this formula. So for this one, what is my Y2? 5 minus Y1, which is over my X2, which is again, minus 2 on the first one. So I get 3 over 0. What is it called when you have 0 in the bottom of a fraction?
Undefined.
Undefined. A vertical line is undefined slope. All right, go to CD. I'm going to do the same process. There's my X1 and Y1. There's X2, Y2. 2 minus 5 over 6 minus 6. Negative 3 over 0. Undefined. What do I know right now? What does that mean? They're the same. I've got the same slope. If you've got the same slope, what does that mean for the lines?
They're congruent.
Not congruent. They're parallel. So right now, I know that these two sides, AB and CD, are parallel. That's all I know. I'm going to do the same thing down here. Except now, BC. I'm going to say there's my X1, Y1, X2, Y2. And then AD, I can leave that. So for BC, tell me the numbers. 5 minus 5 over 6 minus 2. I get 0 over 4, which is 0. Come down to AD, same process. Tell me the numbers. AD, 2 minus 2, 6 minus 2, 0 over 4 is 0. When you get here, this is what you check. Are the first two, or do the first two have the same slope?
Yes.
Do the second two have the same slope?
Yes.
If both of those are yes, then you know, yes, it's a parallelogram. So now I know automatically it's a parallelogram. Well, can it still be a rectangle later?
Yes.
Yes. But all I know right now is parallelogram. Alright. We're going to check, are the first two sides, or the top and bottom the same slope, left and right the same slope? If they are, means it's parallelogram. What if they're not?
Then it's not a parallelogram.
Which means if it's not a parallelogram, what could it possibly be?
Trapezoid.
It could be a trapezoid,
Or a kite.
a kite, or just a regular quadrilateral. So if this is a no, and this doesn't work on the first step, then you're only left with those three things. All right? What if I had one pair of sides that was parallel, and one side that was not?
That'd be a trip.
That's telling me it's a trapezoid. All right? So if we know the rules, this stuff's not so bad. All right. All right, when we do distance formula for the diagonals, if the distance of the diagonals is the same, what could it possibly be? Square, rectangle, isosceles, trapezoid. Now, based on our answer on this previous one where we said it's a parallelogram, if these are the same, which one of those three did we just talk about is thrown out? It can't be the trapezoid. It could be rectangle, square, or isosceles, trapezoid, but we've already said it's a parallelogram, and the trapezoid is not a parallelogram, so that would throw it out. Alright, so here's our formula at the top. We're going to do that formula for each one. So for this first one, I'm going to say 6 minus 2 squared plus 5 minus 2 squared. Here's what I want you to do on the calculator. Type this without the square root on there. Type it without the square root. Just this stuff inside right here. Alright, what is it without?
75.
7? That's not right.
It was 25.
25. You got to type it just like this now, with the parentheses and everything.
I did.
Right.
That's how I did it. 87.
Hold on. Alright, so I'm going to type all of this stuff right here without the square root on there. So I wind up with 25. Then I'm going to worry about the square root part. Alright. In this case, it winds up being 5. So I'm going to do the same thing down here and see what I get. 6 minus 2 squared plus 2 minus 5 squared. Again, make sure you type that without the square root on there. So here, when I do it, I get 25 for the stuff that's up under there, do the square root of that, and get 5. All right, so now what does this tell me?
They're the same.
If these are the same, what does that mean? We've already done parallelogram. This means rectangle or a square. If the diagonals have the same distance, it's a rectangle or a square. So, if the distances are the same, it's a rectangle or square. Well, if these two distances were different, what does that mean? Nope.
Kite.
Correct.
It could be a kite. If these are different, yeah, we're missing the basic ones. It could be a rhombus or a parallelogram. Alright? So if these are the same, it's rectangle or square. If these are different, parallelogram, rhombus, or kite. Alright, again on this, all we're really looking for is it's going to verify whether it's a parallelogram or not. What is the rule about the diagonals of a parallelogram? What do they do to each other? Bisect. Which means they cut each other in half. Well, if they both bisect each other, the midpoint should be the same. So that's what we're looking at here is the midpoint the same on both of them? All right. I'm going to do the same process as before. There's my x1 and y1. There's my x2 and y2. And I'm going to plug the numbers into this formula. So the midpoint of AC would be 2 plus 6 over 2 and 2 plus 5 over 2. That's 8 over 2, 7 over 2, which is 4, and then 7 over 2. I am not going to worry about changing that to 3.5. Leave it as 7 over 2. Just leave the fraction in there. All right, now we've already said this is a parallelogram, right?
Yep.
So what should happen with this second midpoint? It should be the same, because parallelograms have diagonals that bisect each other. Means the midpoint should be the same on both of them. So the midpoint of BD, again, x1 and y1, x2 and y2, 2 plus 6 over 2, and then 5 plus 2 over 2, 8 over 2, 7 over 2. So when I see the same thing, what is that telling me? That it's a parallelogram. Well, we already knew it was a parallelogram. This is just kind of reinforcing that. All right, last step is slope of the diagonals. So I'm going to do my slope formula. Y2 minus y1 over x2 minus x1. So this would be 5 minus 2 over 6 minus 2. 3 over 4. Down here, do the same thing. 2 minus 5 over 6 minus 2. All right, what you're checking for on the slopes of the diagonals is, are they perpendicular? Now, how do I know if something's perpendicular? Well, perpendicular has opposite reciprocals. Do we know what that means?
One's negative, one's positive.
And opposite reciprocals will be something like this. 2 over 3 and negative 3 over 2. That would be opposite reciprocals.
So like they're swapped.
You swap the sign and you
change.
swap the top and the bottom part of the fraction. Did I do that on this problem right here? Are these opposite reciprocals?
Yeah.
They are?
No.
I swapped the numbers and swapped the sign.
Mm-hmm.
All I did was swap the sign.
Mm-hmm.
So these would not be perpendicular. All right.
Isn't that supposed to
Hmm?
the 3, 4, like 6?
I'm just saying this is an example right here.
I don't know about that. 6 minus 4 equals 3, 4.
It's supposed to be 6 minus 2. Yep.
Oh, so
Yep. All right, so what I'm checking is, did this happen right here? Something like 2 over 3 become negative 3 over 2. Well, I had 3 over 4 here, negative 3 over 4 here. So, no, they are not perpendicular. Now, if we go back through this, I said, yes, it's a parallelogram on the first step, right? The next step, I said it's a rectangle or a square. Just verified it's a parallelogram. All right, here. I know it's rectangle or a square. Which one has a perpendicular diagonal? Rectangle or square? Or which one, I guess, is a better question. This one says it's a not perpendicular. So which one of these is not perpendicular diagonals? So then that would be my answer. But it all goes back to knowing the rules. If you don't know what the rules are, this stuff's not going to make any sense. We started by saying, yes, it's a parallelogram. Distance of diagonals told me it was a rectangle or a square. And then here, because they're not perpendicular, means it's got to be a rectangle. All right. If I'm doing AB, well, A is my 1s, and B is my 2's. Tell me the numbers I'm going to plug in right here. 5 minus 2 over 2 minus 1 is 3. 3 over 1. CD, well, C is my 1's, D is the 2's. I get negative 3 over negative 1, which is 3. So what does that mean about these sides right here? They are parallel. So can it be a kite?
No.
The kite is automatically out right now. All right. Actually, I should have graphed this thing first. All right. So it kind of does look like a kite until I do this, and then I prove that it's not a kite. But what could it still be? Parallelogram, maybe a rhombus, stuff like that. So when I do BC, well now B is my x1, y1, and then C is my x2, y2. So I would say 6 minus 5 over 5 minus 2, that's 1 over 3. AD, A is my 1, D is my 2 here. It's 3 minus 2 over 4 minus 1. That's 1/3. So I got the same slopes here. I got the same slopes here. So now I automatically know what? Yes, for parallelogram.
I did it too.
All right, see if we can get this before time gets us. There's my x1, y1, x2, y2. Plug that into the formula. That's going to be 5 minus 1 squared, 6 minus 2 squared. Remember, what did I tell you to do with these?
Do it exactly like that.
Without
The square root.
the square root. So do the numbers and the square part, but leave the square root off of it. What do we get on that? 32? So I'm going to do square root of 32. Now I'm just going to leave it like that for a second. X1, Y1, X2, and Y2. The second one will be 4 minus 2 squared plus 3 minus 5 squared. What is that one? All right. Really and truly, we should work these out and get, you know, the decimal version and all that. All I really care about is, are they the same or not?
No.
So I can tell right now they're not the same. So if the distances are not the same, that means it is not a rectangle or a square, but it could be a parallelogram or a rhombus. And that's all I'm trying to get to at this point. If these are different, it's not a rectangle or a square, which means it has to be a parallelogram or a rhombus. All right? If you give me the decimal version here, that's fine. I'll take the decimal version. All right? We'll pick it up tomorrow from here.